Hi, uh, mic check 1 2 3. So hi guys, uh, today it's Yasser here, back again with another video. So today we are going to cover the entire architecture of Node.js. What really happens behind the hood. So this is one of a kind of video that I used to wish if it exists on the internet, because while learning this architecture and how clustering and child process works, it was pretty really confusing for me personally while I was studying it. So don't worry, I'm here to clear all the things. So just relax and enjoy enjoy the class. Enjoy the session. So basically, what is Node.js? So Node.js basically is a runtime environment which helps JavaScript to run outside the browser. Okay, cool. So how can we what is basically Node.js is providing? It is a runtime environment. It providing a runtime environment, right? So in that runtime environment, I think you have a basic idea that starting from that. Okay, so in runtime environment, we have specifically even libuv, which is the part of thread pool and even loop, and we have the node process. So I will explain by uh, wait a second. I will explain by the basics of computer. So basically, what inside the computer. So in a lab, let's consider our lab as a this, and here we have a motherboard, right? And inside that we have RAM and CPU, also known as processor, which is the brain of the computer. And we have a hard drive and battery, like that is out of the scope. Now what we have to focus on is the CPU. See, so in each CPU we have cores. So basically, let's assume that we have 4 cores, right? So CPU is the main part of our computer, which helps you connect between other things. So here in Node.js, while coming to threads and clustering, CPU is the main part who works on it. Okay, cool. So let's look at how a CPU looks like. Okay, cool. So one core inside a CPU will have a main thread, which basically, let's say we have one core or one processor. Inside that we have a main thread, right? So this main thread is responsible for executing all the JavaScript codes inside the process. Okay, cool. And we can create another threads also. So in this thread, it will have its own stack and other things, right? And the entire process will have a shared memory. So it can communicate each other. Okay, cool. It will have a shared memory at this space. Cool. So this is kind of basics of thing. This is the thing you should need to know before going to it. Okay. Now let's see. Now let's go back to that diagram. So inside this, what happens if you, let's say, if you run your Node.js application, such as Node index.js. Okay. So initially the project will initiate init, and that all the top level codes will be executed. So such as console log, will be maybe registered or executed, not that kind of. And then a require module will work, such as if we are requiring any module such as crypt or any other things, it will work. Then all the callbacks or all the top level code will be registered in callback. Okay, I think you got it. Then we have a even loop. So inside the even loop, we have this. What is this? Yeah, I will show you. So inside even loop. So even loop is the part of Node.js where it handles asynchronous operations. So such as side effects, such as fetching a data from the server or any other things. Okay. So here we have timer queue, IO queue, micro task queue, and check queue and clear queue. So this is a kind of iteration where the callbacks will be pushed onto the call stack or execution context according to the priority. So this is the place where it handles in every asynchronous operations in a single thread. But when it comes to a CPU intensive task, the event loop will offload the task into thread pool. Okay. Okay. So what is a thread pool? So thread pool is provided by libuv, so which is a built-in dependency in Node.js. So in libuv we have thread pool. So what in inside thread pool? So thread pool will parallelly execute these things, and by default we have 4 threads in a process, and it can go up to 1024. So yeah, that's all. So if an CPU intensive task such as FS module, FS read file, or crypto or any other things come, the even loop will say that, hey, I cannot handle this much process. Could you please do this? So the thread will be handle these kind of things. Okay. Now, if all the threads are busy, I mean, we are assigned all the things into 4 cores. Let's assume that we have only 4 cores. So, if all the threads are busy, it will be wait in a task queue, and it will process accordingly. And after that particular task is done, it will assign to the callback or even loop. A particular callback will be assigned to the even loop. So this is a kind of overview how Node.js works. Basically, it will basically if we run it, all the top level codes will assign, and then the even loop callback will register, and even loop will work. And if there is a CPU intensive work, is the even loop will say, hey, I can't handle this. Could you please handle? Will ask to thread pool, and thread pool will handle these kind of things. Okay, cool. Now, let's say if we have a multiple users. Also, this is a one server, right? So if we have millions of requests over here, it cannot handle by all itself. There comes the power of clustering. Okay. So what is clustering basically? Yeah, I will show you. This is something called clustering in Node.js. So clustering in cluster, what basically is doing is it basically creating an instance of the entire Node.js application. So let's say we have this is this thing will work in a core, and another application will work in another core. So this thing will work independently, and it shares the same port. Okay. So it the master. So in while creating cluster in Node.js, we will create a worker process using fork. Okay. While creating a cluster, we have master. So master is the one who load all the task, or assigning or distribute that load into worker processes. So yeah, that's pretty much is about the worker cluster. So we use cluster fork in order to create, and I have not something here. When a request comes in the master process distribute it uh, to one of the available worker process using a round robin mechanism, so that you don't have to worry about it. Like for the sake of this, just understand what is basically working. Each process shares same port. Okay. Each worker process can talk to its parent, which in the sense each I think so. Each process can talk to the parent. And what here the master do is if any process is exited or if any process is killed, it will create another one. So that is distributing the load and creating new processes or worker processes is the main key. Okay, what was that? Okay. Oof. This is very annoying. Okay, cool. So here is a quick code for that. We will import the cluster module and HTTP to do some background work. So initially we will get the number of cores. We will take the number of cores, and here if master is the we will create worker. I mean worker processes. So here we have worker processes, right? So here we can basically send messages, and according to the core, it will create new processes. Okay, so if one exits or die, the master process will create another one. So that's how it works, and this is a quick view of the code. You can check it on ChatGPT or anywhere. So for the context of this video is to get rid of that. I mean get an understanding about what really happens here in cluster modules. So in the end, I will give a brief conclusion, so it won't be that much confusing. Okay. So in child process is a child process. Okay. So child process is also used to do something like this. Okay, let's see what is it's trying to resolve. So in child process we have basically four methods such as fork, spawn, exec and exec file. So in terms of fork, we have it is used to create a new child process that returns a separate script or that runs in a separate script. So it is basically creating a new core or a new process. Okay, and it is suitable for running tasks in a child process. Okay, specific task in a child process, such as operations, computations, IO operations, and other things. Okay, and creates a dedicated IPC inter-process communication channel between parent and child process. So here we can communicate to parent. Okay, cool. And it creates a single process when invoked. So basically, what is the difference between cluster module and fork? Here in child process fork and in cluster modules fork, here basically it's only provides a separate a process and a separate script to execute the code, basically nodes code, right? But here in cluster modules fork, it provides a kind of instance and it can talk to its parent. I mean, it shares the same port and it can automatically distribute the load and everything. So that's the main difference between clusters fork and child process fork. So that's is it, and it executes a separate Node.js process specifically for the file in fork call. So we can give a file to work. Hey child process, I need to work this file separately on a different process. He can do that for you. Okay, cool. Now let's see spawn. Spawn. Okay. Spawn execute a command or a program. Okay, what is it? So, streaming data or running external programs or scripts like shell commands, Python, etc. So, in order to uh, interact with shell commands, we can use spawn. Sorry about that. So using spawn, we can when we can use spawn when we need to interact with no non Node.js executable or commands in the efficiency. So I will explain that. Okay, if you want to run externally something, for example, Python code, we can literally use Spawn in order to work that. So here is the quick code of it. Yeah, you can refer it on anywhere in ChatGPT and everywhere it is. The whole context is to give an idea about it. Okay, cool. Now when it comes to exec method runs a command shell and buffer the output. So we will get the output as buffer, and it is very suitable for short processes, like a small amount of input and output like that. So it is, this is the thing. So this, yeah, after this I will say that. So an exec file will directly execute a file. Basically, if we give any kind of file without involving a shell, this makes more efficient and secure as it avoids overhead and risks. Okay, I think you getting it right. I mean, the kind of explanation is, I think, is far enough. At the end, I will conclude it. So don't be worried about it. You have, I mean, I have wasted this much. Don't be like that. Okay. So we have fork. Basically, everything create a new process. So process in the sense what each process or core is like something in here. Okay. And each process we have separate threads, main thread, and every other things. Okay. In the terms of computer. Okay. Now, what does fork? Is fork creates a new Node.js process that runs in a that runs the specified script with IPC communications by default. The child process have its own memory and context. Okay, as I said. Now let's look at spawn. Creates a new process to run an external program or command suitable for streaming large data as the child process as the standard IO. So what does spawn is do is basically create a new process which can handle a large bunch of data, and we can do that in parallelly. Okay. And in terms of exec, it also creates a new process to execute shell commands, and it will give buffers as output. And it is basically for short execution. I mean, yeah, like that. An exec file creates a new process to directly execute a file, script or binary without involving a shell. It is faster, secure, but lacks shell functionalities. I think you're getting it. Okay. Now, when we look at the scalability, we have concurrency and parallelism. So when it comes to scalability, we have we with the help in terms of concurrency, with the help of even loop, we can concurrently run the tasks accordingly. But in terms of parallelism, we have work threads, child processes, cluster module, thread pool in order to work things in a parallel manner, which means everything works in a second. But in concurrency, it will every task will split in a second manner. I mean, in a millisecond manner, like that. Okay, cool. So yeah, one more thing we have to cover. So in worker threads. So basically, what is worker thread? Worker thread, we have also a worker thread module. It allow us to run JavaScript code in a separate thread, but it will be in the process. It runs in the same process, but we can run the task in a separate thread. Okay, I will explain that thing to avoid that conflict. So basically we can run the things in the process, but the thread will be another. We can create a new thread and execute our JavaScript code inside that. Okay, cool. So that is pretty much it. So let me conclude. So Node.js is a runtime environment which allows to run JavaScript, provides a runtime environment which allows to run JavaScript outside the browser. Okay. And in Node.js, in terms of parallelism, it provides cluster module and child process. So what does cluster module is do? It will create an instance of the application according to the core. Okay, and the port will be same. Mhm. So each instance have its own even loop and thread pool and everything. So it will be each instance will be in each process. Okay, and in terms of child process, we can create new processes accordingly. So with the help of fork, spawn, exec file, which creates a new processes accordingly. So in terms of fork, we can create a new process to run node scripts accordingly, and with the help of spawn, we can execute or program. Sorry, we can execute a bunch of Python files or any other things, Python commands or anything inside another process. And in terms of exec, it helps to run shell commands, and exec file it helps to run another file inside a new process. So that's pretty much it about the architecture of Node.js, and I hope you understood. I mean, you have understood. And if you have any kinds of doubts, you could ask in the comment section. And pardon me if my knowledge is not wrong. I mean, it's actually pretty accurate, but I just want a disclaimer. This is what is based on what I have researched. So yeah, that's all from my side. So thank you for watching this far. That's all. Thank you.